we will study techniques of water distribution in the farms. So there are various ways of applying water to fields. आपने जो पिछला topic पढ़ा, that was types of irrigation. Now irrigation has come to the grassroots. It has come to the field operation. So the methods of irrigation, how water is applied to fields or farms or crops, are as follow: free flooding, border flooding, check flooding, basin flooding, furrow irrigation, sprinkler and drip irrigation. We will discuss them one by one. First of all, free flooding. Let me give a summary of all the methods. There are two main categories. One is flooding. See, flooding. चार bullets जो हैं, चार types जो हैं वो flooding से related हैं. Free flooding, border flooding, check flooding, basin flooding. What is meant by flooding? From flooding we mean surface irrigation, yani water is applied to the surface of the fields in a free way, maybe in somewhat restricted way, but mostly in a free way, right? Where in furrow irrigation and sprinkler and drip irrigation we go for the economy. इसमें पानी अप्लाई किया जाता है लेकिन ज़रा सा control manner से. So these are the two main categories. In free flooding we dig a main ditch which has been labeled in the diagram. This diagram is self-made, not taken from any book. I have given you the book. If you want to go for that diagram, it's okay. This was only for my record. The field is covered with ditches. There is a main ditch, and the main ditch then branches out into subsidiary ditches. Subsidiary का मतलब है secondary ditches. ठीक है? And in this way the whole of the field is covered. Now the blue line shows the water flow. पानी main ditch में आता है and then it goes into each subsidiary ditch, and from each subsidiary ditch it goes out into the field and irrigate the crops. So all the blue points, everything is labeled. The main ditch is labeled, subsidiary ditches are labeled, flow of water is labeled, water. लेकिन पहला जो arrow है, how it is shown, this first arrow, how it is shown, this is represented as water flow through main and subsidiary ditch. Okay, main ditch and subsidiary ditch. Okay, now what's the second blue arrow? Water flow into the field. From the subsidiary ditches, water then flows into the field on both sides of the subsidiary ditches. This is called free flooding. Free flooding is called free flooding because movement of water is unrestricted, right? It is not restricted. बहुत खुले तरीके से पानी apply किया जाता है. There is also a picture taken from real-time scenario. No need to spend effort and expense on leveling the field. No need is required to level the field. You just apply water. So उसका क्या नतीजा है कि water economy will be compromised, यानी बहुत ज़्यादा पानी अप्लाई होगा तो कुछ ना कुछ वेस्ट, बल्कि काफ़ी सारा वेस्ट भी हो सकता है. It has been mentioned. It means too much water is consumed and hence will be easily wasted. This method is fit for closely grown crops. If the crops are closely grown, the method is good because most of the field will be adequately supplied with water. Subsidiary ditches are spaced at 20 to 50 meters. ये ditches and subsidiary secondary ditches, इनका जो फासला है, they are spaced at a distance of 20 to 50 meters. The subsidiary ditches distance are at 20 to 50 meters. I should have mentioned it over here, लेकिन फिर बहुत ज़्यादा congested हो जाना था diagram. So ये कोई इतनी बात नहीं है. You can these are branches. Subsidiary ditches are branches of the main ditch. So you can give out these branches at a distance of 20 meter, 30 meter, 40 meter, 50 meter, whatever you like, or whatever the type of the crop is, depending upon, ये लिखा भी है, depending upon the slope of the field, texture of soil किस texture का, type of crop. Okay. Now comes the method border flooding. अच्छा, border flooding में क्या है कि in border flooding, first of all, diagram is drawn. Now in this again free water is applied in flooding form. Free water is applied to the field, but here we do something different. We divide the whole field into strips: strip 1, strip 2, strip 3, strip 4. These strips are separated by borders. ये borders हैं, यानी पिछला जो था वो ditch था. These were ditches, यानी इसमें आपने खुदाई की, excavation was done. And in this method, dumping is done. Borders are made. Borders may be about 6 centimeter to 10 centimeter high. ठीक है, borders are made and the strips are created. These strips could be 100 to 600 meter, 100 to 400 meter. 400 meter would be more appropriate. ये मैं जो आपको PPT send करूँगा तो उसमें मैं 400 कर दूँगा, because too much long strips are not good, because then water will be not efficiently applied. अच्छा, width should be 10 to 20 meter. Okay, and this is, here we have got a main ditch. This is called the main ditch. No need to go into, I will label it. Okay, I will label it for you in the PPT that I am going to send you. So this is the main ditch, and in main ditch we see water flow, and from the main ditch water then enters each of these strips and irrigate the cropland. Water entry into strips. So these are borders and they are also called levees, border flooding. Let's go into further detail. ये तस्वीर भी है साइड पे कुछ real time scenario की. Land is divided into number of strips separated by low level borders. Each strip is 10 to 20 meter in width and 100 to 400 meter in length. The border levees should be of heights 10 to 15 centimeter to avoid overtopping of water. To avoid overtopping of water from one strip to another, the border levees should be of 10 to 15 centimeter high, and strip land should be leveled. जाहिर बात है, each strip should be properly leveled to avoid concentration of water. यानी आपने तो ठीक है borders को तो आपने you created borders of 10 to 15 centimeter high so that each strip water share should be restricted. लेकिन जो ऊपर नीचे की जो reach है, upper reach and lower reach, so it should be, the strip should be properly leveled so that water concentration should be avoided in upper and lower reaches. And the main ditch size depends upon the rate of infiltration. जो main ditch size है, its size can be large, its size can be medium, its size can be less, or let's say somewhat small. So the main ditch size depends upon the rate of infiltration of soil and width of each strip. If the infiltration of soil is more, so it means water will be quickly absorbed and thus the ditch size should be more. यानी ditch बड़ा होना चाहिए अगर आपकी मिट्टी जो है वो porous है, permeable है, coarse है, ठीक है, fine के बजाय coarse है, high infiltration rate है उसका, तो उसमें पानी बहुत जल्द जज़ब हो जाएगा. तो पानी जो आप सप्लाई कर रहे हैं that will get absorbed in the upper reaches. What about the lower reaches? What about the right of the strip, the left of the strip? So for that purpose you have to give the main ditch of a larger size so that much water is introduced into each single strip. Fine texture soil has low infiltration rates and coarse texture soil has got high infiltration rates. ठीक है. So likewise you have to, so similarly you have to decide this size of the ditch accordingly, according to the infiltration rate. तो ये border flooding की दास्तान हो गई, ये इसकी explanation हो गई, and this is the diagram for border flooding. And यहाँ पे free flooding में आप देखें कि ठीक है. Okay. Now there is a small question involved in this border flooding. What is that question? We will first discuss a formula. You have to remember it. You have to practice it. No need to go into proof of this formula, right? Because we have much more to cover in irrigation engineering. For interest sake, you can see the reference book. What is the formula? Formula is for calculating time of irrigation of a strip, in how much time an irrigation strip land could be irrigated. So T is equal to 2.3 bracket start Y by F brackets close log to the base 10 bracket start Q divided by Q minus FA. Q minus FA को bracket में होना चाहिए था, parent small brackets में. That I will do in the slides. Anyways. What is T? T is the time required to cover the area A. T is the time required to cover the area A. Okay. Area is the area of the land. or strip that is to be irrigated, and F is the rate of infiltration of soil, the soil जिससे वो ज़मीन बनी हुई है. Q is the discharge through the supply ditch, कहाँ से पानी आ रहा है उस नाली की में जो पानी आ रहा है जो मेन नाली है मेन ditch है, its discharge. Y is the depth of the water flowing over the strip of the land, यानी how much water will be flowing over the strip of the land approximately. ठीक है ना, ऐसा नहीं है कि कोई आप यू कीप ऑन कंसिडरिंग और कैलकुलेटिंग कि ये तो कुछ वेस्ट हो गया, कुछ एवेपोरेट हो गया, कुछ सीप हो गया. हाउ एम आई गोइंग टू कैलकुलेट द डेप्थ ऑफ वाटर ओवर द स्ट्रिप? अप्रॉक्सीमेटली. You have to calculate it approximately. So there is a question based upon this formula. It's easy question. पहले भी मैं पोस्ट कर चुका हूँ, लेकिन anyway, let's go into it. Determine the time required to irrigate a strip of land. 0.04 hectare strip है, ज़मीन का एरिया है, ट्यूबवेल से सैराब होगा. 0.02 cumex is the discharge. Infiltration rate is 5 centimeter per hour. 5 centimeter per hour. Average depth of flow over the field is 10 centimeters. So the average depth of flow over the field is 10 centimeter. So also find the maximum area that could be irrigated by this much water. So 1 hectare आपको पता होना चाहिए 10⁴ मीटर स्क्वायर है. अगर पता नहीं है तो अब के बाद पता होना चाहिए. 1 hectare has got an area of 10⁴ meter square. ठीक है, that's why I have written the unit in full form. So area is converted into meter square. The 10⁴ क्योंकि the given area is 0.04 hectares, तो ये area 400 meter square हो गया. डिस्चार्ज 0.02 क्यूमेक्स है. क्यूमेक्स का पता होना चाहिए कि मीटर क्यूब पर सेकंड को कहते हैं. नहीं पता तो अब पता होना चाहिए. 0.02 अब सेकंड को हमने आवर्स में चेंज किया क्योंकि इरिगेशन हो रही है, मैक्रो लेवल पे बातें हो रही हैं. ऑन ए मेजर स्केल यू आर डिस्कसिंग थिंग्स और कॉन्सेप्ट. सो हियर सेकंड will not be involved. You bring into action hour एक यूनिट है बड़ा टाइम का, तो वो ले आए. That's why we convert it from second to hour. So 1 second is equal to how much hour? 1 second is equal to how much hour? 1 second is equal to 1/60 hour. तो जाहिर बात है वो कन्वर्जन कर लें आप. अच्छा, ये है सेंटीमीटर पर आवर, तो सेंटीमीटर इज कन्वर्टेड इनटू मीटर, तो 5/100 will become 0.05 meter per hour, and depth of water over the surface of the soil is 0.1 meter. Though in irrigation engineering जो कमिंग लेक्चर है उसमें, बल्कि वो जो मैं पोस्ट भी कर चुका हूँ, आपको ड्यूटी डेल्टा का आइडिया होगा, लेकिन दिस आई एम पोस्टिंग अगेन ऑल दीज लेक्चर्स और रिवाइजिंग माई लेक्चर्स अगेन. आपको आइडिया होगा हम सेंटीमीटर को ज़्यादा इंपॉर्टेंस देते हैं, बट दैट इज़ इन द केस ऑफ डेल्टा. नाउ हियर इन दिस न्यूमेरिकल यू गिव इंपॉर्टेंस टू मीटर एंड आवर. नथिंग टू बी सो फसी अबाउट. इतनी कोई बड़ी कोई बुरी बात नहीं हुई. तो टाइम का फॉर्मूला जो विच वी डिस्कस्ड प्रीवियसली इज अप्लाइड, एंड दैट्स इट. आंसर कम्स आउट टू बी इन आवर्स. आवर्स से उन्होंने वैसी रीडेबल बनाने के लिए मिनट्स में कन्वर्ट किया. मैक्सिमम एरिया दैट कैन बी इरीगेटेड, उसका फॉर्मूला है ए मैक्स इज इक्वल टू डिस्चार्ज बाय एफ. अगेन it is easily understandable. Everything is easily understandable. Simple numerical. Okay, now comes the turn of check flooding. Check flooding is actually an improvement upon basin flooding. Basin flooding in border flooding, what we did in border flooding, we made strips.